Hello and welcome. This is Mouse Gunner, and in this video I'm going to talk about long recoil operated systems in firearms. The example we're going to look at in this video is the Browning Auto 5, which is significant because it is the longest production run of a firearm utilizing the long recoil operated system. The Browning Auto 5 was produced from the late 1800s all the way up into the 1990s. There was also a variant of the Browning Auto 5, the Remington Model 11, which was more or less the same firearm, just produced by Remington rather than under the Browning name. But in any case, let's go ahead and show the function of the firearm. I'm going to start off X-raying this down so we can see the moving parts. I am going to start zoomed out, and then I'll zoom in as I'm discussing the function of the firearm in more detail, because there's a lot that goes on during the functioning of a long recoil operated system, and I want you to be able to see all of the parts involved. We're going to start off at normal speed initially. We're going to slow it down to half speed. And then finally, we're going to do it a little bit slower. So the first thing that's going to happen is with the trigger pull, we're going to drop the hammer. The hammer is then going to strike the back of the firing pin here, igniting our shell. And then we have the beginning of our recoil impulse. Now this operates initially somewhat like a short recoil operated system. This is a lock breech design. The bolt and barrel are locked together, and the barrel and bolt do travel rearward together. But unlike a short recoil operated system, the barrel does not stop at some point and then the bolt traveling the rest of the distance. Instead, the barrel and the bolt travel the entire length of the recoil and then unlock from each other, which we see happening right here. At this point, the barrel travels forward under the tension of its own recoil spring, which it compresses as it recoils backwards, which we can see kind of in reverse happening. So this is the compression of that recoil spring there. Once it unlocks, that spring brings it forward. Once the barrel is fully forward, we have the ejection of the old spent shell, and then the shell from the magazine is lifted up in front of the chamber and then driven into the chamber by the return of the bolt. So now let's talk about the main functionality of a long recoil operated system as seen in the Browning Auto 5. The first main element is the locking and unlocking of the bolt and the barrel from each other. The second element is, after the bolt and barrel have traveled fully rearward and unlocked from each other, what keeps the bolt to the rear while the barrel travels forward? So let's first look at the locking unlocking element of the Browning Auto 5. And this utilizes a locking block mechanism, just like as I discussed in my short recoil operated video. So as we travel to the rear, we see our locking block right here, dropping down, unlocking the bolt from the barrel. We can see the locking block within this cutout in the top of the barrel. And as the bolt and barrel recoil backwards, the locking block will tilt downwards, and once it is tilted far enough that it is no longer within the cutout and the barrel will then travel forward under the power of its own recoil spring. Let's go ahead and look at this under a little bit more detail by X-raying down, and we can see the locking block within the bolt. You can no longer see the barrel other than a silhouette. We can see the tilting down of the locking block, and eventually, once it's reached a low enough level, the barrel will unlock from the bolt. Now, how this works, we X-ray down a little bit further, we will see the locking block here, which is a pretty sizable piece. And another element that is important here is how the locking block cams. And it does this because the bolt is actually a two-part piece, which you might just be able to make out here. So initially, with the bolt and barrel lock together, the bolt starts to get pulled forward by the recoil spring of the barrel. As it gets pulled forward, we can see this piece right here that runs through the bolt, acting upon this sloped surface. So this pin rolls along this surface, which pushes this surface forward. As it pushes it forward, it then acts upon the rear of the locking block, camming along it. This sloped surface and this sloped surface meet, tilting downwards on the locking block. So it is a dual camming action. So let's X-ray this out a little bit so we can see the pin through the bolt as a top part of the bolt, which we can no longer see the lower part of the bolt unless we come out a little bit further. As that comes forward, it rolls along this piece here, which is also the back of the firing pin, interestingly enough. Rolls along this piece, which is going to then cam along the locking block, tilting it downward. So it's a pretty complex interaction going on. And that is how the bolt and barrel are unlocked from each other. So now let's talk about how the bolt and barrel lock back together when the bolt comes forward. I'm not yet going to discuss how the bolt locks back. I'm going to save that for a little bit later. But as we watch the cycling of the action, I'm going to have to bring this X-ray back again because it's important to see the locking block and how it functions. So at the moment, the locking block is being held in the downward position by this piece here. It's spring-loaded, and it's going to act upon a cutout in the bottom of the locking block here to keep it locked in the downward position. The reason this is done is so that the locking block does not come back up until it has come forward into the cutout in the barrel, because we don't want it prematurely locking. So this holds it in place, and we can see this happening as the locking block tilts downward. Eventually, this piece is going to fit up because of its the spring-loaded nature of it into that cutout, locking the locking block down. Now, how it overcomes this is due to the attachment of the locking block to this piece here, which is acted upon by the compressed recoil spring here. So as we watch this come forward, the recoil spring is going to push upon this piece, which pivots along this pin, pushing the bolt forward. Once the bolt comes completely forward, this piece here is going to unlock from the locking block, allowing it to tilt upward. And how this happens is because of that pivoting piece. Once it is pivoted enough, there is a finger on the very end of this arm that pushes downward on the spring-loaded piece. Once it pushes downward enough, it's going to free the locking block from this locking piece, allowing it to then pivot upward again. And it's going to be the continued forward push of this arm that's going to pivot the locking block upwards. We can see that happening there. And then the barrel and bolt are again locked together. We have one more main function of a long recoil operated system as seen in the Browning Auto 5 to discuss, and that is the locking back of the bolt as the barrel travels forward. And this is achieved by the interaction of this spring-loaded arm with the bolt. So as the bolt travels to the rear, it's going to push backwards on the spring-loaded arm. The spring-loaded arm then pivots along this pin here and rotates downwards underneath the bolt. As the bolt reaches the rear extent of its travel, the spring-loaded arm is going to come up into a cutout in the bolt locking the bottom portion of the bolt in place. We can see the spring-loaded action happen. If we X-ray down a little bit more, here's our spring, and right now the spring-loaded arm is underneath the bolt, but as we bring the bolt to the rear, the arm is going to come into this cutout as the spring pushes along this portion of the arm. The arm pivots along this point and goes upwards into the cutout, locking the bolt backwards. With the bolt locked backwards, the top portion of the bolt is pulled by the barrel. The locking block pivots down. The barrel unlocks from the bolt, traveling forwards. Once it reaches its forward travel, the old spent shell is ejected, but we'll note that the bolt is not coming forward yet. After it is ejected, our new shell is lifted up, and we can see if we keep an eye on that spring-loaded arm, as the shell lifter comes upward, so too does the spring-loaded arm pivot. Once it pivots downwards enough, the bolt is unlocked and allowed to travel forward yet again. This happens because the pin that this spring-loaded arm was previously pivoting upon is right here, attached to the shell lifter. And as the shell lifter pivots upward, so too does the spring-loaded arm pivot downward. As the spring-loaded arm pivots downward, it unlocks from the bolt, allowing it to come forward. But let's take a look at what causes the shell lifter to move in the first place. And this is an interaction between a couple pieces and the shells in the magazine tube. So this piece right here is holding back the next shell in the magazine tube, which we can just see. It's holding back the rim of the shell, not allowing it to come into the receiver and onto the shell lifter. But the magazine spring within the magazine tube is pushing upon these shells, trying to push them in there. So as long as this piece is holding back the shell, it will not come into the receiver and onto the shell lifter. But as the barrel travels forward, this piece is going to enter a cutout in the barrel, but as we can see, there's a slope at the end of this cutout that this is going to pivot along. Once it pivots out of the way, the shell can then be pushed by the spring and the magazine tube out onto the shell lifter. I move to the other side of the firearm to see what happens next. And as the shell gets pushed rearward onto the shell lifter, it's going to come into contact with this lever here. Now this lever is spring-loaded via this flat spring here, and the spring is pushing outward on the lever. And with the lever in its outward position, it is coming into contact with the shell lifter and locking it in place and preventing it from moving upward. But as the shell slides along this lever, the rim of the shell is going to push upon the lever, pivoting it inwards. And once this lever gets pushed inwards far enough, it's going to unlock the shell lifter and allow it to freely travel upward. With the return of the shell lifter, the lever locks back in place because there's no longer any shell acting upon it. And the next shell is held in place the whole time by this lever. So we can see, if we back up, as the shell is pushed onto the shell lifter, while it pivots the lever on this end is going to hold back the rim of the next shell, holding it back slightly. And it's not until the shell lifter comes back down, allowing the spring to push this lever outward, that the shell is then going to come forward again. But when it starts to come forward, it's going to be held back by the bolt. And then when the next cycling of the action occurs, this piece here will hold back the shell as it advances a little bit further into the action, but preventing it from traveling far enough to act upon the lever, which then allows the lifter to come upward. Now let's discuss what actually drives the shell lifter upward and then returns it back down. Well, the first element that drives the shell lifter upwards is the same spring that acts upon this arm. So as the shell lifter unlocks, this spring, which is compressed, then pushes outward on the shell lifter, which we can just see the shell lifter silhouetted here. And that's what drives the shell lifter upward. Now, what drives the shell lifter back down is actually on the other side. And it's this flat spring right here. As the shell lifter gets pushed upwards, it compresses this flat spring. And although the animation here is a little sloppy and actually shows the spring clipping through this part of the shell lifter, we can see as the shell lifter comes down, it's the flat spring on the other side that is acting upon it, bringing it back down. And this occurs because the arm initially is going to resist that motion of the flat spring. But once it comes free of the back of the bolt, it's no longer resisting that. And at that point, we have the shell lifter coming back down. So as the arm slides along the camming surface of the back of the bolt, we have our initial allowance of downward travel of the shell lifter. But once it comes free of the bolt, and the shell lifter can then pivot downward freely, that flat spring brings it down the rest of the way, locking it in place with the lever. Another interesting element of the operation of a Browning Auto 5 is the fact that you can actually manually activate the lever to unlock the shell lifter. And it's done by this button. So if we come out, you can actually see the button sticks out in the receiver. And this is because the firearm does have a last shot hold open. And we can demonstrate that here in a second as we cycle through. We see the last shot in the magazine holding back the bolt. The reason this happens is because we don't have a shell on the magazine to act upon the lever, allowing the shell lifter to come up. And it's the shell lifter coming up that unlocks the bolt and allows it to travel forward. So if we were to reload the shotgun, or even if we didn't want to reload the shotgun, we just wanted to drop the bolt, we would do so by pushing on this button. Pushing on this button acts upon the lever, allowing the shell lifter to come up, which is going to drop the bolt closed. That's kind of an interesting element of the design, that not having another shell in the magazine tomb is not going to allow the unlocking element of the bolt to happen, and it just stays locked back. Very interesting and frankly brilliant design. Some other examples of firearms that utilize the long recoil operated system include the Remington Model 8 and its variation, the 81, which was a successful early era semi-automatic rifle. It was produced in the early 20th century all the way up to the early 1950s, and it was chiefly sold in the civilian market. It never earned any military contracts. Another example is the Shosho light machine gun used by the French military during World War I. This is notorious for being a piece of junk, but honestly, the poor Shosho gets kind of a bad rap. It was more the variants that were given to the U.S. military that were modified to accept the 30-06 cartridge that were the truly unreliable firearms. The ones that were originally designed to take the 8mm Lebel functioned all right enough. There were some design issues, chiefly in the magazine, that caused some complications in the trenches, but the overall function of the firearm was decent for the time period. Another notable example is the Frommer Stop. Now, the two big designers of the long recoil operated system are John Browning, which not only designed the Auto 5, but he also designed the Model 8 as well, and Frommer, who is a Hungarian designer that was responsible for a couple long recoil operated handguns. The Frommer Stop being the most successful of the variants that he produced, but there was also a 1910 variant that was a long recoil operated handgun as well. So if you're interested in Frommer and his handguns, I'm going to include a couple links in the description. They're going to talk about those in a little bit more detail. Before we talk about differences of the examples I've just given to you in functionality with that of the Browning Auto 5, I think it's important to go over the similarities. One of those similarities is that all long recoil operated systems will have two recoil springs, one for the barrel and one for the bolt. Now, where these springs are located and how they function is going to be one of the big differences between some of the examples I've given you. For instance, the Remington Model 8 does not have a magazine tube, so the spring isn't on the outside of the magazine tube. Instead, it's on the outside of the barrel itself, in between the barrel and a sleeve that goes on the outside of the barrel. Another similarity is the fact that they're all lock breech designs. But that's also going to be the difference in how they lock together the barrel and the bolt, and then unlock them. For instance, you could have the locking block design that you have in the Browning Auto 5, or you could have a rotating bolt design, or any other number of ways that you could lock a bolt to a barrel. Would work just fine in a long recoil operated system. The important element is the fact that it is a lock breech design. Another difference is how the bolt is locked back when the barrel travels forward. For instance, the Remington Model 8, again, does not have a magazine tube or a shell lifter, so it's going to have different functionality to lock back the bolt in the rear position while the barrel is traveling forward, but it also doesn't have the same considerations that the Browning Auto 5 would have, in that you have to allow for time for the shell lifter to lift the next shell into line with the chamber before the bolt can go forward. And the Remington Model 8, the bolt can go forward as soon as the barrel comes to its complete stopped forward position, because the magazine and the next cartridge in the feed lip of that magazine are already in line with the chamber. So you just need to bring the bolt home. You don't have to wait for the shell lifter to come up. So that's one of the big differences that you'll also find. And for instance, the show is an open bolt design, so it's going to function a little bit differently in the way that it locks back as well, because under normal conditions, when not being fired, the show's bolt is already going to be locked to the rear, and the bolt is going to be fully forward. So it's going to be the pull of the trigger that drops the bolt forward, and not some other mechanism, which actually simplifies the long recoil operated system quite a bit when compared to the closed bolt variants of a long recoil operated system. With all that said, let's now go over the strengths and weaknesses of a long recoil operated system. And I'm going to start with a weakness rather than a strength, as it's one of the biggest considerations of why the long recoil operated system hasn't been more successful. And it's something that you may have noticed when I was going over the operation of the Browning Auto 5, and that's its complexity. There's certain elements of a long recoil operated system that always have to be there for it to be a long recoil operated system. It always has to have two recoil springs. The barrel and the bolt always have to recoil together. They have to lock and unlock from each other. The bolt has to lock back when the barrel is traveling forward. There has to be some mechanism that locks back the bolt and then unlocks it when it needs to come forward. All of these things add complexity, and they need to be there. There's no way for them not to be there. And this is one of the biggest problems with a long recoil operated system. The complexity of the firearm makes it more expensive to produce, harder to produce, and it adds to complexity of disassembly. When the owner of the firearm has to disassemble it, there's so many parts that need to come out before the rifle can be disassembled. I think this is especially problematic in some particular designs. I think the Browning Auto 5 is one of the designs that has the least issues with this. It's still a little bit more on the complex side when compared to other firearms. But for instance, the Remington Model 8 is very complex to disassemble. There's certain things that need to come out of the firearm before you can get the bolt out, and various other elements. As a result, this isn't as user-friendly. Militaries aren't going to be as interested because they want something that even an idiot can disassemble with no tools. I mean, that's the ideal. So this is mostly going to be something that is successful in the civilian market because they're not as concerned with such difficulties, but it's still going to be something that is going to sway sales. And also the price is going to sway sales. With that complexity, more can go wrong. Anything from a weak spring to a broken part can disrupt the reliable operation of the firearm. And considering how many springs and parts are necessary for the operation of a long recoil operated system, it's just all the more that can go wrong. With that said, let's now talk about the main strength of a long recoil operated system, and that's the strength of its action. This is a lock breech design that keeps the action closed for a remarkably long time, the entire rearward travel of the bolt. This does an excellent job of dissipating the built-up gas pressures in the chamber, which is especially relevant for rifle design, as early semi-automatic rifles really struggled with dealing with these built-up gas pressures. The long recoil operated systems were some of the first that could really deal with those pressures and function reliably, which is the reason why they were popular in the era they were popular. Another disadvantage, which could possibly be perceived as an advantage depending on your thinking, is the cycle time of the firearm. It's a lot longer than some other operating systems, and although you might not really notice it in a semi-automatic firearm, with a fully automatic firearm, there is a noticeable drop in fire rate. And when I say fire rate, I mean rounds per minute will be significantly reduced when compared to other operating systems used in fully automatic firearms. For instance, the Show is a good example of that. It had a pretty slow fire rate when compared to other machine guns of the time. Now, as I said, you could spin this to an advantage if you want. A slower fire rate is a little bit more controllable than a fast one, especially in a light machine gun or fully automatic rifle platform. And it also expends ammunition a little bit slower if you're concerned about such things. But there are also advantages to a higher fire rate that you would miss out on in a long recoil operated system. In any case, that wraps up the strengths and weaknesses of the long recoil operated system and an overall look of the functionality of a long recoil operated system. I know I discussed a lot more disadvantages than advantages with a long recoil operated system, and I think that hints at why you don't see long recoil operated systems really used anymore. It doesn't really mean that long recoil operated systems are bad. It just, they do have a number of disadvantages, but that advantage that they have that I did discuss, the strength of the action, really does make up for a lot of them. But when you compare it to a modern gas-operated system and all the advantages that that system has, it's hard to overcome it when you have so many disadvantages bringing you down. It's not that I think that a long recoil operated system has no future, but it would take quite a lot of redesigning and simplifying to really justify such a system in the modern era. So I hope you guys have enjoyed this video. This is Mouse Gunner signing out.